Today we'll start oxidation test. Even this is also it is a test to identify primary, secondary and tertiary alcohols. It is used to distinguish which is primary alcohol, secondary alcohol and tertiary alcohol. Already what are the two tests we saw? Lucas test, Victor-Meyer's test. I think you remember that. So in Lucas test, based on the turbidity formed, we identify the type of alcohol. Similarly, in Victor-Meyer's test, we are using colors, variation in colors to identify the type of alcohols. Now, let us see this oxidation test, which is very useful to you. See, ethanol. In this ethanol, single bond CH2OH, if it is coming, it is said to be primary alcohol. When one alkyl group is attached to the alcoholic group, it is said to be primary alcohol. So, primary alcohol generally on oxidation. For oxidation, we are using this acidified potassium dichromate or acidified sodium dichromate. Here they are taking acidified sodium dichromate, which is one of the most powerful oxidizing agent. Whenever we are using this acidified sodium dichromate, at that time this primary alcohol on oxidation we said, that is why it supplies nascent oxygen. So this hydrogen, oxygen, together water it is eliminated. Finally it is giving CH3CHO, that is acetaldehyde. So what does it mean in the sense? Primary alcohol on oxidation gives aldehyde. Here we are taking ethanol, that is why it is giving acetaldehyde. Clear? This aldehyde on oxidation, it is giving acid, carboxylic acid, acetic acid. So ethyl alcohol on oxidation gives acetaldehyde, that on oxidation gives acetic acid. Final product is acetic acid. Similarly, when we are taking secondary alcohol, how we are saying that it is secondary alcohol? Because two alkyl groups are attached to this alcoholic group. So that it is saying to be secondary alcohol. Secondary alcohol on oxidation with acidified sodium dichromate. Same acidified sodium dichromate here also we are using. At that time, this two hydrogen and oxygen together water it is formed. Here primary alcohol on oxidation gives aldehyde. Secondary alcohol on oxidation is giving ketone. This ketone again on oxidation it is giving the same acetic acid. Primary alcohol, final product is acetic acid. Similarly, even secondary alcohol also it is forming acetic acid. Basic difference is that here acetaldehyde on oxidation gives acetic acid. Here acetone on oxidation gives acetic acid. Here number of carbon atoms, when we are comparing two carbon atoms, here also same two carbon atoms. So same number of carbon atom it is coming here. Whereas in case of secondary alcohol, 3 carbon atoms, here it is 2 carbon atom. So this is the basic difference. This you are going to study in detail in biomolecules unit. Is it clear? One more important thing is that we are adding pyridinium chlorochromate. Mark it in your book, it will be one word. Pyridinium chlorochromate, it is used in this aldehyde state so that it can prevent the oxidation. When we are using this PCC, here aldehyde will not be further oxidized to acid. Similarly, ketone will not be further oxidized to acid. So to prevent oxidation, we are using this pyridinium chlorochromate. Clear? Now we are taking tertiary alcohol. Here 3 alkyl groups are attached to this alcoholic group. This tertiary alcohol at normal temperature, it is not at all reacting. It doesn't show any reaction. But when we increase the temperature, that is why elevated temperature. On increasing the temperature, it is giving a mixture of carboxylic acid. So, based on this oxidation test also, we are able to differentiate primary, secondary and tertiary alcohols. In next class, we will see the Swan oxidation. Thank you, students.